Good morning, students. Yes, under electrostatics, next lecture. Yes, it is one new topic for you, that is charging and discharging of capacitor in series RC circuit. Okay, if capacitor and resistor they are connected in circuit with battery, with cell, that is DC source. This battery means it is DC source. What happens when it is connected with AC source? That we will see in alternating current, AC. Okay. So yes, here see, one capacitor is connected with resistor, with this battery it is switched. Okay. What happens? See, potential difference between two ends of cell. Battery is V0, capacitance C, and resistance R. As this switch is closed, obviously current flows from the circuit. Okay, and yes, this capacitor gets charged. So yes, as shown in figure A, when switch is closed, capacitor starts charging. Okay, yes, current is also flowing from this resistor. So in this transient state, potential difference appears across capacitor as well as resistor. So we can write V0 is equal to V plus V dash. Okay, this potential difference appears across capacitor as well as resistor. But when this capacitor gets fully charged, this on potential of battery that appears only on capacitor. From see this figure, this total potential difference appears only between two ends of capacitor, nothing left for this resistor. So yes, when capacitor is fully charged, entire potential difference appears only across capacitor, nothing left for resistor. Clear? And yes, it is called steady state condition. So whenever in circuit you are given capacitors as well as resistors, and capacitors are fully charged, you can neglect resistors in series. Simple. Yes or no? Yes it is. So yes, here you can neglect these resistors. In steady state, you can neglect this resistance. Okay. Now, during charging of capacitor, charging means, yes, from this first figure, see, this capacitor is initially uncharged. No charge is stored on plates of capacitor, and it is connected with battery. So during this charging process, when charge is stored on capacitor, during that condition, what is charge on capacitor at time t? Q is equal to Q0, 1 minus e raised to minus t upon RC, where R is resistance, C is capacitance. Potential difference across capacitor at time, V is equal to V0, 1 minus e raised to minus t upon RC, where what is V0, it is potential difference provided by battery, where what is Q0 is maximum charge on capacitor in this condition, maximum charge when potential difference is V0. So yes, I can write that Q0 is equal to it is CV0. I can write that Q0 is equal to it is CV0. Simple? Yes, it is simple. And similarly, as we have two equations for charging, we also have two equations when the capacitor gets discharged. Get discharged means this battery is removed. Capacitor is fully charged. So charge now flows throughout this resistance. So during discharging process, when battery is removed, capacitor gets discharged. So what is equation of charge at time t? Q is equal to Q0 e raised to minus t upon RC. V is equal to V0 e raised to minus t upon RC. Simple? Yes, it is simple. Now, one important point for this theory, that is time constant. Now, what is time constant? See, time constant, but what is time constant? RC is called time constant. RC is equal to, it is called time constant tau, because its dimensional formula is equal to dimensional formula of time, and it is time during charging. If charge of capacitor becomes 63% of Q0, means maximum charge, it's 63%. Initially charge on capacitor is 0, increases. When it becomes 63% of maximum charge, that time it is called time constant. Or during discharging, total time during discharging when charge falls to 37% of initial charge. 37% of initial charge. So yes, this definition you have to remember. Okay, what is definition of time constant? Because yes, sometimes in MCQ theoretical questions there may be asked a time constant doubt, that is RC, that you have to remember. Okay, so yes, it is one RC circuit, that is one extra case that you have to remember. Now we will see one question based on RC circuit. See, let C be the capacitance of capacitor discharging through a resistor R. Discharging through a resistor R. Let T1 is the time taken for energy stored in the capacitor to reduce to half its value, and T2 is the time taken for charge to reduce 1/4 its initial value. Then ratio T1 upon T2 will be. See, let the CV capacitor C discharging, means initially it is fully charged. Fully charged. So if capacitor is fully charged on it, it is Q0, and its initial energy U0 is equal to, it is half C V0 square. Yes or no? Yes, U0 is equal to, it is half C V0 square. Simple. Yes or no? Yes, it is. U0 is equal to, it is half CV0 square. Now, what you have to find? Let T1 is the time taken for energy stored in the capacitor to reduce half of its initial value. Yes, it is discharging process. So in discharging process, charge from plates of capacitor decreases. Charge decreases, so its energy also decreases. And yes, T1 is time taken for energy stored in capacitor to reduce to half its value. To reduce to half its value means, yes, here U is equal to, it is U0 by 2. U is equal to, it is U0 by 2. Yes or no? Yes, it is. What is U and what is U0 by 2? U means, yes, U means it is, yes, it is Q square, or yes, you can write it is half CV square. This side it is U0. What is U0? Yes, here it is U0. It is 1 by 2. It is 1 by 2 half CV0 square. Simple? Simple? Yes, it is simple. So yes, this half cut, this C cut, and this C cut. Okay. Now what is equation of V? What is equation of V? For discharging process, we know equation of V. Okay, V is equal to V0 e raised to minus T upon RC. So how to write this equation of V square? Yes, it is V0 square e raised to minus 2 T1 upon RC, because energy is half at time T1. So V0 square e raised to minus 2 T1 upon RC is equal to, it is 1 upon 2 V0 square. It is 1 upon 2 V0 square. Simple? Yes, it is simple. V0 square cut, V0 square cut. I can write this as 1 upon e raised to 2T1 upon RC is equal to 1 by 2. So therefore, e raised to 2T1 upon RC is equal to 2. Logarithmic function and exponential function, they are inverse functions. So therefore, if I take exponential function on this side, it will 2T1 upon RC is equal to log 2. And therefore, T1 is equal to, it is RC log 2 divided by, it is 2. That is equation number 1. That is equation number 1. So yes, it is time T1 during which its energy reduces to half. Now what is another statement? Another statement is T2 is time taken for charge to reduce 1/4 of its initial value. 1/4 of its initial value. Yes, what is equation of charge? Equation of charge. That is Q is equal to Q0 e raised to minus T upon RC. Yes, you are given T2 is time taken for charge to reduce 1/4 of initial value. Means it is Q0 by 4 is equal to Q0 e raised to minus T2 upon RC. Q0 by 4 is equal to, it is Q0 minus T2 upon RC. Clear? So yes, Q0 cut, this Q0 cut, it is 1 upon 4 is equal to, I can write 1 upon e raised to minus T2 upon R6, sorry, it will become plus, yes, it will become plus. So e raised to T2 upon RC is equal to 4, simple. So therefore, T2 upon RC is equal to, it is ln4, yes, it is ln4, and therefore T2 is equal to, it is RC ln4. But this ln4, I can write this ln4 as, therefore T2 is equal to RC ln4 means it is 2 square, and there is one rule for logarithmic that this power you can write as coefficient. So therefore T2 is equal to, it is 2RC ln2. It is 2RC ln2. And now as we have to find the ratio T1 upon T2, it is T1 upon T2. What is T1? It is RC ln2 divided by 2. And divided by T2. Divided by T2 means this term. It is divided by T2 means it is 2RC ln2. So ln2 cut, RC cut is equal to, it is 1 upon 4. Is equal to, it is 1 upon 4. So yes, your answer is, it is 1 by 4. Simple. So yes, it is one question which is based on RC circuit, and say it is discharging process. That's why we have used these equations. If V is equal to V0, E is to minus T upon RC, and Q is equal to, it is Q0, E is to minus T upon RC. If it is charging condition, then we have to use another equation. Clear? So yes, it is one question which is based on RC circuit connected to battery, means DC source. Next question is based on capacitors. See, what is question? What is potential difference between points A and B and between B and C in steady state? Yes, you are given 1, 2, 3, 4, 5 capacitors, 2 resistors and 1 battery. So yes, you have to find what is potential difference between point A and B and between B and C. So see, first of all, it is point A. It is one another point. Let we name this figure. For example, it is A, it is B, C, D, E, F, G, and here it is H. Okay, for example. Now see this A, this B and H. These all are common points. These all are common points because there is no electrical component between these points. Similarly, E, D and C, they are common points. Now you are given one word, that is steady state. And yes, we have discussed in RC circuit, in steady state, when capacitors are fully charged, no voltage appears across end of resistor. No voltage appears across end of resistor. So yes, potential difference between ends of this two resistors is 0, means we can ignore these 2 resistors. Okay, we can ignore these 2 resistors. Now see this capacitor, its 2 ends, G and H. This capacitor, its one end is G, another end is B. But see, B, A and H, they are common points. Means these 2 capacitors have common ends. Their one end is at G and another end, yes, it is this. Okay, so yes, these 2 capacitors are in parallel connection. Similarly, these 2 capacitors are also in parallel connection. See, its one end is F, its one end is F, its another end is, they are connected, they are common point. So yes, these 2 capacitors and these 2 capacitors, they are in parallel connection. Yes or no? Yes, it is. Then how to reconstruct this figure? I can draw this figure again like this. Like this. Okay? 3 and 3 microfarad. They are in parallel connection. So what is their parallel connection? It is 6 microfarad. This 1 and 1, they are in parallel connection. What is the equivalent capacitance? It is 2 microfarad and it is 1 microfarad. Here it is 100 watt. Clear? Now see, this H, A, B, A, these all are common points. So I can write A here also. Okay, this C, now this resistance is neglected, see. So this C, D, this C and E, they are common points. So I can write this C here. Simple. Okay, so yes, it is point B. Now what is your question? You have to find potential difference between two ends, A and B, and as similarly between B and C. Between B and C. Okay, so now how to find this potential difference? How to find this potential difference? That we will see. See here, these two branches, they are in parallel connection. Parallel connection means, yes, what is potential difference between A and C? It is 100 watt. What is potential difference between these two ends? It is also 100 watt. Yes or no? So I can draw like this. It is A, it is B, it is C. Okay, and potential difference between these two and it is 100 watt. It is 100 watt. Okay, so yes, it is of 6 microfarad and it is of yes 2 microfarad. These two capacitors are in series connection and potential difference between them is 100 volt. So yes, I can write this 100 volt is equal to, it is VEB plus VBC. It is VEB plus VBC. So 100 is equal to, yes, charge on series connection is same. Charge in series connection is same. V is equal to, it is, yes, it is Q upon 6 microfarad. It is Q upon 6 microfarad plus here it is Q upon, yes, Q upon, yes, it is 2 microfarad. Simple. So yes, if I take Q common, here it is 100. Then 100 is equal to, it is Q common. The addition means 6 plus 2, it is 8 microfarad. Okay, and divided by, it is 6 into 2 means it is 12. 6 into 2 means it is 12. Simple. So if I make Q as subject, so therefore Q as subject, then Q is equal to, it is 12 into 100 divided by 8 microcoulomb. Simple. Simple. Okay, Q is equal to, it is 12 into 100 divided by 8 microcoulomb. Okay, now how to find VAB? Yes, here it is this equation. See, VAB is equal to, it is Q upon 6 microfarad. What is Q? It is 12 into 100 divided by 8 and here it is 6. Micro will be cancelled out. Okay, so yes, it is 6 into, here it is 6 into 2 means it is 200 and 200 divided by 8. Now 200 divided by 8 means 200 divided by 8 means it is 100 divided by 4, 25. 200 divided by 8, it is 25. So VAB is equal to, it is 25. Similarly, what is VBC? What is VBC? VBC is equal to, it is Q upon 2 microfarad. 2 microfarad. So yes, what is value of Q? It is 12 into 100 divided by 8 and here it is, okay, so yes, it is 2 into, here it is 6, okay, then it is 3 into 2 and here it is 4 into 2, it is 4, 25 into 3 is 75. It is 75 volt, and if you add these two values, you will get it is 100 volt. You will get it is 100 volt. So yes, that is one simple question, okay, which is based on connections of capacitors and resistors. How to find VAB plus VBC? It will be 100 volt. So yes, with this you can verify your answer. Yes, if VAB is equal to 25, you can directly write 75 because we know that VAB plus VBC is equal to 100. You can directly write this 75 volt. Clear? Okay.